Okay, so first question we're going to take a look at is solving a quadratic, and we're going to use the quadratic formula. Okay, so we want to identify what A, B, and C are before we plug anything in. Okay, so let's start with those. Anybody tell me what's A in this case? Yep, 1. And B? B, yeah, 3. And C? Yep, that's
-7.
-7. So we've got A, we've got B, we've got C. Now we'll fill them all in. So we've got negative B plus or minus square root of B squared minus, and what's going to be in the parentheses after the -4? Yep. 4, and then what did you say?
1.
1 and -7, yep. And we're going to divide all of that by, we're going to divide by, yeah.
2 times 1.
2 times 1, which is?
A.
Well, what's 2 times 1?
1. 2.
2. Okay. So now we've got it all set up. We're going to be subtracting a negative, so we can cross the negatives out right away. And then 4 times 7 gives me how much? Travis?
28.
28 plus 9 gives me 37 divided by 2. And that's as simplified as we can get because the square root of 37 cannot be broken down. Any questions on that one? Yeah.
Do you do 2 separate answers, like -3 minus the square root of 37 and -3 plus the square root of 2?
If you were going to type that in on Elastic, I would probably have to, or pair assessment, I would have to put 2 separate boxes because I don't think they have that symbol the way I would need you to use it. Yeah, I'd probably put 2 separate boxes.
And you don't want the answer to the decimal, you want it as the fraction.
Yeah, we want it as an exact answer unless they specifically say round to 3 decimal places. If there are any you can round, I'll let you know on the test. Any question how to convert that to a decimal? By typing it in on the calculator? Yeah, okay. So to get that as a decimal, we're just going to type in, I usually do the numerator first, square root of 37. So that's the top, divided by 2. So one of the answers is 1.54, it's 2 decimal places. And then -3 minus the square root of 37. And divide that by 2. So the other answer is -4.54. Yes?
Where's that fraction button that you use when that in my class to convert us to a fraction?
So the fraction button, if you've got something like 3 divided by 4, if you press math, the first option there says fraction. If you press that, it'll take the number that you had typed in and change it to a fraction.
Does that work for repeating, like 0.3 or whatever?
Yeah, it would work for repeating. Like if it was like that and you change it back to a fraction, that would be fine. If you type that in by hand, I don't know. I don't think so. No, because that's not really 1/3. That's 0.3333333, which is not 1/3. Yeah.
For a quadratic formula, would you want the -3 plus much, or would you want the -4 point?
I would want most likely the exact answer.
Okay.
Yeah. Yeah. Exact answer. Okay. So the next one we're going to take a look at is solving a quadratic again, but this time it's by factoring. So first thing we want to do is put our 2 sets of parentheses. And this equation doesn't have anything on the other side. So we can just put equals 0 because it already was all on one side. If it wasn't, I would want to get everything on one side first, just like I was doing quadratic formula. All right. Now, first thing I do is figure out what's going to be the first term in each set of parentheses. And what would we need as the first term So when we multiply them together, we get 2x squared. Yeah.
2x.
Yep, we're going to need a 2x and an x. And now, because the signs are minus and minus, what does that tell me about my signs down below? Yep.
It's gonna need positive there.
Right, you're going to need one of each, and it does make a difference which one we put where. We might not know right now, but do you have a guess at which one is going to be the positive?
The X.
Okay, we can try the positive with the x, try the minus there. And now 12 is a little annoying because there's a lot of things you can multiply to get 12. We got 1 and 12, 6 and 2, 3 and 4. It's going to be one of those combinations. Anybody have one that we want to try first? Well, let's pick one and just try it. Remember, you saw how I created this problem. Yeah.
3.
All right, let's try the 3 and the 4. And which one? Where do you want to put the 3?
3 negative 4 positive.
3 negative and 4 positive. Okay, let's try it. So if we check it, we've got 2x squared. That gives us plus 8x minus 3x. Is 8x minus 3x negative 5x? Okay, 8x minus 3x, Noah, what do you think?
Yeah.
8x minus 3x, that's negative 5x?
Oh shoot, wrong symbol.
Yeah, wrong sign. So what do we have to switch to make that work now?
The signs.
Yeah, we just have to switch the signs. All right, so that's a minus 4. That's going to be a plus 3. Now if you check it, it's negative 8x, and that's a plus 3x. And 8x, negative 8x plus 3x is negative 5x. So now we factor it. Once we factor it, what do we do with each factor? Yeah.
Set it equal to 0.
Set them equal to 0. So you get x equals 4 from the second factor. And what would you get from the first factor? Yeah.
Negative 1.5.
Yeah, you could do negative 1.5 if you want to leave it as a fraction. That's fine too. So there are your two answers by factoring. Any questions on that one? Yes.
Is there any easier way to figure out that factoring thing, or is that just like, is it like process of like guessing?
The factoring thing, so there are other methods you can use. I don't use them myself, so off the top of my head, I can't remember how to do it. But there are methods that some people use that it's a little bit less trial and error. At least 2 was prime here, so we knew it had to be a 2x and a 1x. And we knew it had to be a plus and a minus. The real variable was the 12. So your options would have been 1 and 12, 2 and 6, and 3 and 4. So worst case scenario, you would have had to try 3 things before you found the right one.
So on the test, is there going to be a non-prime coefficient for x squared, or
It's possible you could have something here that's not a prime number. I mean, I'm not going to give you something like 96, because then, I mean, you've got a lot of possibilities. But you could have something like 10x squared. So then you'd have to try like 1 and 10 or 5 and 2. So you have 2 options to try instead of 1 option. But you can always do quadratic formula as well. It's a little bit longer sometimes, especially if the factoring pops out at you quick. But you can always do quadratic formula if you had trouble with the factoring. Yeah. Okay, so next question we're going to look at is solving an absolute value equation. What's the first thing that we have to make sure of? start an absolute value equation problem. Yep.
The absolute value is isolated?
Yep. Gotta make sure the absolute value is isolated. Is it isolated in this case?
No.
Can you tell me, no, what I would need to do to isolate it?
Subtract 3.
Subtract 3. And subtract 3. Okay, so that's gone. We don't have to do out what's in there. We can just leave that for now. That's not a problem. But now the absolute value is isolated. So what are we ready to do with that problem now? Yeah.
Split it into 2 equations.
Yeah, we're going to split that into 2 equations. What's going to be the first equation that I split that into? Yeah. Lynn?
Would it be 2 parentheses x plus 4 equals 7?
2x plus 4 equals 7. And can someone else tell me the second equation that I split that into? Yep. Matt.
2 parentheses x minus 4 equals 7.
So the 2's good. That's good. But we do want to change something, but not quite what you had said to change it. But it is something with a minus. Right?
2 parentheses x plus 4 equals negative 7.
2x plus 4 equals negative 7. Okay, now we have to solve each equation. So it's going to give me 2x plus 8 equals 7. So we get 2x equals negative 1. Or x would equal, yeah, negative 0.5, or you could also say negative 1/2, either way. Yep. So that's your first answer. And second answer starts out the same, 2x plus 8. But this time it's equal to negative 7. So we're going to get 2x equals negative 15. And we can leave it as a fraction. What would be our answer for x? Yep.
Negative 15 over 2.
Negative 15 over 2. Perfect. So that really covers solving an absolute value equation, and it covers solving a linear equation because it's split into 2 problems that were linear. So that kind of covers both. Any questions on that? All right, so this one we'll take a look at is solving absolute value again, but this time it's an inequality instead of an equation. So what's the first step we have to make sure of, even if it's already done? What do we have to check? Yeah.
The absolute value is isolated.
Yeah, make sure the absolute value is isolated. This time I gave you one that already was. Last time it wasn't. Okay, so absolute value is isolated. So we're ready to split. Anyone think they could give me one inequality that's going to split into? Yep, Andrew.
3x minus 6 is greater than or equal to negative 10. Or I guess 3x minus 6.
Okay, so 3x, we'll put that one over here, is greater than or equal to negative 10. Yep, that's the harder one because you got to do a couple things to it. Now the other one is the easier one. What's that one? Yep.
3x minus 6 is less than or equal to 10.
Less than or equal to 10. Okay. That one is exactly the same as the original. We just take away the bars. The one on the right, we took out the bars, but then we flipped the sign and we changed the number on the other side to its opposite. Okay, and one more thing. We need need a word in there. Travis?
And
Right, this is a less than, so we're gonna put and.
Okay.
And now we solve it just like we would an equation. What's the only other thing that can happen though when you're solving an inequality that you have to be careful with, and this doesn't come up with an equation? Yeah.
If you multiply or divide by negative, you have to change the sign.
Right, if you multiply or divide by a negative, you need to flip the sign. Okay. Don't think that's gonna happen in this one, but if it did, we would have to fix that. Okay, so solving the inequality on the left, 3x minus 6 less than or equal to 10. What's my first step? Oh, Maria, what's my first step?
Add 6 to,
Yeah. Add 6. And Savannah, my last step.
divide by 3 over 6.
Divide by 3. So this is a case where I don't know what 16 divided by 3 is as a decimal. I mean, I could figure it out. It's 5, it goes in 5 times and a third left over. But just leave it as 16 thirds. So x is less than or equal to 16 thirds, and do the same steps for your other inequality. Add 6, divide by 3. So 3x is going to be greater than or equal to negative 4, which means x is greater than or equal to
Negative 4 thirds.
-4 thirds. Okay. Any questions on splitting an absolute value inequality or then solving each linear inequality? All right, let's take, those have decimals. I want to do one a little bit different for the next part. Let's say that you solved an inequality, and when you were done, you ended up with something like x, this new question, x is less than or equal to 10, and x is greater than 4. Okay, it's not what we got here, but let's just pretend we solved an inequality and that's what we got. I'd like to write this first together as one kind of with one variable in the middle. How would I write this with the x in the middle? Yeah, no.
4 is less than x, and x is less than or equal to 10.
Yeah, perfect. So that's not really a different format. That's just a shorthand inequality, and the one above it is the long way to write the inequality. Now what I want to do is write, instead of an inequality, let's do set notation. How would I write that compound inequality in set notation? Yeah, Travis?
is it parentheses 4, comma 10 bracket?
Yep, perfect. 4, comma 10. Remember, 4 is the lowest value you are allowed to use. 10 is the highest value. And then the parenthesis indicates you can't equal 4. And the 10 means you can. So that's set notation. And now let's graph it. Okay, so how would I graph the answer to that problem?
Yep. 4 would be an open circle,
Open circle on 4, yep.
and then a closed circle.
Closed on 10. Yeah, and just don't forget to shade in between. Okay, when you have this kind of inequality, you do not shade in one direction with an arrow. Right? You always have to shade between. Not saying you won't have one tomorrow where you won't have to use the arrow, but at least in this problem, you do not. So, any questions on those 3 different notations? Okay, so that's important to know. All right, so this one is an equation they've given us. Now, they could give us this all distributed out as well, right? It's just I wanted to make one up that had certain characteristics, and that's an easy way for me to do it. Now, if I ask you how many roots that equation has, what am I asking you to find? What's another way of me asking that question?
How many times it crosses the x-axis?
Yep, how many times it crosses the x-axis? And what's one other way we could see that word? Yeah? How many zeros does the graph have? Okay, so to figure that out, the first step is to type it in. And you have to set a window that's going to allow you to see all the times it could cross the x-axis. If you distributed all of that out, you would end up with something to the what power? I don't care about the whole thing. I just want to know what the highest power would be.
3rd.
That would be to the 3rd power. It would be an x cubed. And I told you that when you have something that's cubed, it can cross the x-axis up to 3 times. Might not always cross 3, but it could. So we've set a window. We hit graph. And now we should be able to see how many roots this graph has. So how many roots does this graph have? Choice. Yeah, it has 3. So 3 roots. Now I could also ask you to find them. Okay, so this is where we'd have to use the calculator because that's a cubic, and we might not always get nice answers. Now, in this problem, I know the answers are going to be 2, -5, and -4. But if that was all foiled out, you wouldn't be able to tell that easily. So let's pretend we don't know that formula. How do we find a 0 on the calculator? What do we have to press?
Second and trace.
Second, trace. And then which option do you pick?
2.
2. And then remember, it's going to ask you 3 questions. First, it's going to ask you to pick a point that's somewhere to the left, then a point somewhere to the right. And then the last thing it's going to ask you for is the guess, which you can really put anywhere kind of close to it. And as we expected, 2 is one of the numbers you can plug in and get 0. If I asked for the other ones, you just have to do second calc 0 2 more times, and then you could get all 3 answers. Okay, so 2 is a 0, 2 is a root, and the coordinate 2, 0 is an x-intercept. So there's different ways you can say your answer. But is there any question on how we calculated the root on the calculator? All right, so next question we're going to look at is a investment problem involving simple interest. Now, simple interest, that is a formula we went over in class. So that's one that you should know. It's probably the only formula that we did this week that might not have been something you've done before. I don't think we had any other formulas or equations like that. But what's the formula for simple interest? Yeah.
I=PRT.
Right, it's I equals PRT, principal times rate times time. So when you're doing an investment problem where somebody is investing $12,000 in 2 different investments, you have to find the interest that they earn separately in each investment. Then we can combine them together to figure out something involving the total. So let's start with the 7%. the interest at 7%. Well, we don't have any variables yet, so we need to pick a variable that's going to represent the amount of money in the 7% account. What would be a good variable for that? Yeah,
X.
X. Okay, so X is going to be the amount of money in the 7% account. So what does that mean we're going to have in the 8.5% account? Yeah.
12,000 minus X.
Yeah, the balance. So you're going to have X dollars in the 7% account and 12,000 minus X in the 8.5. It doesn't matter which one is the single variable. The only difference is going to be when we solve this, potentially which answer you get first. That's all. We're going to get the 7% answer first, and then we'll get the 8.5 after. Okay, so interest at 7%. How much money are we investing at the 7% in the 7% account? Yeah,
Is that X?
that's your X. What's the number we use for the rate in the 7%? Yeah,
0.07.
0.07. And the problem in the book said that the person, I think, is doing this for 1 year. Okay, so time will be 1. Okay. When we clean that up a little bit, can we get 0.07x for the first one? Okay, let's do the 8.5. So interest at 8.5%. What's the principal for the 8.5? Yeah,
12,000 minus X.
12,000 minus X. What's the rate for this account? 0.085. And what's the time? Well, what was the time for the first one? Okay, so we're gonna multiply that out, and then we'll clean that formula up, and then we'll be done with the two separate, and then we can combine. So we got 12,000 times 0.085, and that gives us 1020. So that's going to be negative 0.085x plus 1020. So we've got a formula for each amount of interest separate. Now we want to get a formula combined together. When I combine the two interest formulas together, are there any like terms?
X?
Yeah, the x's. Right? We can combine those together. So 0.07 plus negative 0.085. So that's negative 0.015. And there's nothing to combine with the 1020. It's the only constant in the two equations. Okay, so now we've got a formula that represents the total interest. How much total interest did this person earn for the year?
$900.
They earned 900. So where does that 900 get plugged into our total formula? For the,
Oh, or the X, or the high total. It's either or.
it is either or, yeah. It would be one of those two locations. Where does that 900 get plugged in? Yep. Total, right? This is a total amount of interest. It's not the amount of money at the 7% rate, all right? That's what X is, and we don't know that. We're solving for it. Okay, so subtract 1,020 and then divide by negative 0.015. So when you subtract 1,020, you're going to get negative 120 on the left, and then divide by negative 0.015. So that's $8,000 for X. And what was X again? Which account was that? That's the 7%. So we got $8,000 there. And how much money does that leave for the 8.5% account? $4,000. Yep. And that's a pretty typical interest rate. Any questions on that? Okay, so this one is from the book. Again, on page 89, I think it's number 25. It says we're making a rectangular table, and it's 625 square inches. And that's pretty much all it tells. So the first question is to write a formula that relates length and width. All right. So we know we have area, and this is a formula that I wouldn't tell you. Okay, so you'd have to know the formula for the area of a rectangle, which is, what is that? What is it? Length times width. And then all we can do is fill in what they gave us. Where would the 625 get filled in? Yeah.
The A spot.
For A, yeah. So 625 equals length times width. Okay, and that's all I wanted you to do. Now, the next part, question 26, says solve for L. Okay, how would you get L by itself in that equation? Yeah. Divide by W. So 625 divided by W equals L. And the last part they ask us to do is graph it. All right. So let's think a little bit about the width. Is there a minimum value that the width could be? That it couldn't really go any lower than this. Yeah?
0.
Yeah, it can't go any lower than 0. Right? So we definitely don't want to go lower than 0. Is there a maximum value for the width? No, not really. I mean, you could have a rectangle that's 5,000 units long and like 0.01 inches wide. Right? So you could do that. So there's no maximum. So we'll just put in 200. But what starts to happen what's going to start to happen if the area stays the same and the width is getting bigger and bigger and bigger and bigger? What would happen to the length? If the width is going to keep getting bigger, that's okay, but you've got to keep the area 625, so what would have to happen to the length?
It would decrease.
It's going to have to decrease. Yep. So let's put this in and see what it looks like. Remember, we have to use X. And if we hit graph, let's look at our window. So what you're looking at there is not a great window. Let's set this to 0. And let's set the Y max at like 50. What you're looking at there is a graph of the lengths in this problem. The bigger that you make the width, the lower the length is getting. Because the width is getting bigger, so the length has to get smaller to keep the 625 area. Same thing, if you make the width really, really, really small, then the length has to get bigger to compensate to keep the area the same. So that's a good graph, and you wouldn't want to be looking at negatives because you can't have negative width and you can't have negative length. So you should only be looking at quadrant 1. And you're never going to be able to see the whole graph. This just goes up forever, and that just goes to the right forever. But that's a good window. So if they asked for a window, I would say that's good right there.